Alright guys, let's go into 2.5 today. So 2.5 is actually very similar to what we just covered in 2.1 and 2.2, except we're talking about transformations of the quadratic functions. But they follow very similar principles and rules, okay? So this shouldn't be any problem. This should be a pretty quick lesson. But horizontal translations and vertical translations of the quadratic function. Just as a reminder that this right here is the parent function of your quadratic function, okay? So right there, that's your parent function. So whenever you have a horizontal translation, it's pretty much the exact same as we were talking about before. It happens whenever you have an x minus h, but instead of just being x squared, you have in parentheses x minus h, and that is being squared. Okay? And just like before, whenever h was less than 0, you were actually shifting over this way. So basically what that meant was, so again, if we have an example of h equals negative 2, again, that's h is less than 0, then we would have f of x minus negative 2, right? Which was equal to f of x plus 2. So actually, whenever you're positive, you're going left to the negative direction, and when you're negative, you're actually going to the right in the positive direction, okay? Okay, so that's just a refresher, but it's following the same principles, right? So when h is greater than 0, so when h is 2, so then you have x minus h, you're going in the positive direction. But whenever you have h is less than 2, which really means that you're adding 2, you're going in the left direction. All right. Now for the vertical translations. You can see here that's still the same as before. We have our function plus k. So that's equal to x squared plus k. Alright? And then whenever 8k is positive, greater than 0, you're going to go up. You're moving your function upwards like that. And then when k is less than 0, you're moving your function downwards, moving it down. So shifts down when k is greater than 0, shifts up when shifts down when k is less than 0, and shifts up when k is greater than 0. And then the reflections across the x-axis and y-axis, it's still the same, guys. I'm probably just not going to really talk about this much, but it's still the same. Again, this is a vertical reflection across the x-axis is a vertical reflection, and then across the y-axis is a horizontal reflection. So here on the vertical reflection across the x-axis, you have a negative x, which is outside of our parentheses right here. You can see our negative's outside, so we flip it across the x-axis. But notice here for the horizontal reflection, our negative is inside of our parentheses, and whenever you square a negative number, well, you just get a positive number, so it's the same. So you can see that there's a reflection across our y-axis, but the thing is, our function is symmetrical across the y-axis, so it doesn't actually affect what it looks like. Okay? Okay. Now horizontal stretches and shrinks, similar to what we talked about in the previous unit, but whenever a is inside of our parentheses, then it's going to be stretching horizontally like this. So we stretch away from the horizontal stretch away from the y-axis when a is less than 1 but greater than 0, and a horizontal shrink toward the y-axis when a is greater than 1. Okay? And backwards, opposite, when we have a vertical, it's away from the x-axis when a is greater than 1. That's a stretch. And then vertical shrink towards the x-axis when it's between 0 and 1. So again, notice that these are away and towards the x-axis. And the a happens outside of our f of x, not inside of the parentheses. Okay? Okay, so that should just all be material from the previous unit 2.2. So it's all very similar. So I just have some examples to go over here. So let's go over this first one. So first it says to describe the transformations of f of x equals x squared represented by g of x. Okay, so this is g of x, and we want to know how this is different from the parent function f of x equals x squared. Okay, so we can see here that we're adding 4. So that means it's a vertical shift if we're adding 4 and it's not inside our x value right here like it is on number 2, but we'll get to that one. So that means we're moving f of x up 4 units. So our vertex of our quadratic function starts at 0, 0, right? So we're moving our vertex up 4 units, which would be right there, since our scale is by 2. Okay, and then we would have a something like that. So that would be our new quadratic if I were able to draw it a little bit better, but you guys get the idea. Okay, so we moved the vertex, the whole function, up 4 units. Alright, here for number 2, we have a horizontal translation, -1, and we have a vertical translation, down 3. But remember, like we said up above, that whenever it's minus, you're actually moving in the positive direction. Okay? So we're going to go right 1. So our vertex starts at 0, 0. We go over 1 unit and then down 3 units. So it should be about right there. Just like that. Okay? So pretty simple. The shifts are pretty easy. And then for this last one right here, we have x plus 9. So that's a horizontal shift. So when it's positive, though, we go in the negative direction. So we're going to go to the left 9 units, and we do not have a vertical shift. There's nothing happening like a plus or minus k out here. So that means we don't have anything going on. What we do have is this negative right here, which whenever it happens outside of the parentheses is a vertical reflection across our x-axis. So first of all, let's plot our vertex. So f of x squared starts at 0, 0, and then we're saying that we're going to the left 9 units. So 1, 2, 3, 4, 5, 6. So that should be about right here. Alright, and then normally we would draw it up like this right here, right? But because it's negative, it's actually a reflection across the x-axis right here. So we're going to face this downwards like this. Alright? Okay. For number 4, x squared minus 7. So we have our x squared, and the minus 7 isn't inside of our any parentheses, isn't being squared. So that's a vertical translation, and that is going to be down 7 units. Again, whenever it's a k value, down means towards the negative. Minus means towards the negative. So we're going to start here, but we're going to move our vertex down 7 units, which should be about right there. And there's no reflection or anything going on, so it just looks like that. Okay, now we're getting into our stretches. You can see here that we're multiplying x squared by 1/3. So this is happening outside of our squared. Like here in number 6, you can see -4 is being multiplied by the x and it's inside parentheses. So that's horizontal. But in this case, we're talking about a vertical stretch or a shrink. So if we go back up, vertical stretches and shrinks say that it's a shrink right here. It's a shrink towards the x-axis when a is between 1 and 0. So 1/3 is between 1 and 0, so we have ourselves a vertical shrink. Okay? First, let's plot our vertex. So we start at 0, 0. We have a vertical shift down 6 units. So that is right there. And now we're going to stretch or shrink. In this case, we're going to stretch. So that basically just means that if it's we're going to shrink. So that means instead of looking like this, we're going to look more wider, like this. Okay? I'm not going to plot out the points, just generally I'll just show that it's going to look more wide like that. Although that might be like a overestimate of how much we're shrinking, but I just want you guys to get the idea that that's what it is. Yeah. So it looks more like that, but probably not that extreme. Okay, so for number 6, the -4 is happening inside of our parentheses. So whenever it happens inside, that's horizontal. Our a is 4. We're not thinking about the negative, we're just talking about 4 right here. So a is greater than 0. And so that means we're going to shrink towards the y-axis. So that means that instead of looking like this, we're going to shrink towards the y-axis, so we're going to look more like this. Again, that's a horizontal shrink by a factor of 1/4. Remember from the last unit, we said that we read it backwards, so it's going to be a horizontal shrink by a factor of 1/a, so 1/4. We don't have any sort of shifts, so our vertex is still at 0, 0, but we do have this negative right here, which means that we're going to flip it across the y-axis. But remember that our function x squared is symmetrical, so that actually doesn't affect what our graph looks like. It's still going to be the same as if it were not negative. So again, we're going to have a shrink, so that just means that we're going to look more skinny, a horizontal shrink. We're going to look more skinny like that. Okay, so that should cover all of our transformations, or at least give you an example of what our transformations look like. Okay, and these aren't really any different from anything else that we've covered so far, so it should be pretty easy to grasp. So it says, consider the function f of x equals -10 x minus 5 squared plus 7. Describe the transformation of the graph of the parent quadratic function. Okay, so the parent quadratic function, which is f of x equals x squared. So let's make a list of what we see. So we have a -5 inside of our parentheses. So that means it's going to be shifted to the positive direction, right? So we're going to say shift right 5 units. And then we're going to add 7 outside of our parentheses. So that's shift up 7 units. And then right here, we're multiplying outside of the parentheses. So we have a vertical stretch by a factor of 10. And then we have a negative outside being multiplied, so that means a reflection across the x-axis, or you can say a vertical reflection. Okay, so really not too bad. Again, we're just talking about principles that we've already covered before, but we're applying them to the quadratic functions, and it works out pretty similarly. Okay, so if you have any questions, make sure you email me, bring your questions to class, and I will see you then. Thanks, guys.